Good day, students. Welcome to this revision session on chemistry, IGCSE, syllabus code 0620. In this session, I'm just going to focus on a question which came in May-June 2015. The question was on stoichiometry, chemistry calculations. Students normally find these calculations very challenging, and I thought I should just take some time to go through with you this question which came in May-June 2015. So let me just share my screen so that you'll be in a position to look at the question, and then we look at the expected answers together. All right, so this was the question. It was talking about the equation for the decomposition of copper 2 nitrate is given below. So we have our equation there. And then C part 1 was reading, predict what you would observe when copper 2 nitrate is heated. So there's thermal decomposition of this salt, which is becoming copper oxide. So copper 2 nitrate is decomposing to copper 2 oxide. And then there's also nitrogen dioxide produced and oxygen produced. Okay, so we want to predict what we observe here. Okay, remember, questions that you get on observations, you have to tell the examiner what you pick with your senses, not what you think. Okay, so observation is usually your sight, your touch, even what you hear. All right, so I'm just going to write the expected answer here. I will type what you should write. Okay, so copper 2 nitrate is being changed to copper 2 oxide. All right, so we are going to see a color change here. So in my answer, I could say the blue, okay, crystals, blue crystals, okay, are changed to a black. Okay, let me just extend this so that we can have our answer in one line. Okay, the blue crystals are changed to a black. I will extend this again so that I can write the word powder. Okay, the blue crystals are changed to a black powder. Okay, the blue crystals is copper 2 nitrate, and the black powder is obviously your copper 2 oxide. That's observation number 1. Okay, but you also actually find out that there is nitrogen dioxide which is produced. Of course, oxygen, I can't tell that is oxygen until I perform the test. But nitrogen dioxide, I can tell that. Okay, why? Because nitrogen dioxide is actually a brown gas. Okay, so we could also say a, okay, brown gas, a brown gas with, okay, with a pungent smell, all right, is produced. Okay, so you as having two things here is produced. So we are saying observations have to do with your senses. Blue crystals changing to a black powder, you're using your sense of sight. Okay, a brown gas, again, you're using your sense of sight. And a pungent smell, now that's your sense of smelling. So whenever the examiner is talking about observation, please make sure that you use your senses to actually write down the observation. What you do use to write down the observation. Okay, so that should suffice for the first question. Okay, as I scroll down my screen, I may actually rub those answers so that you could be in a position to see what is below there. Okay, copper 2 nitrate forms a series of hydrates with the formula Cu, open bracket, NO3, close bracket, 2XH2O. All these hydrates decompose to form copper 2 oxide. 1 mole of copper 2 nitrate X H2O forms 1 mole of H2O. Now, that is very, very important. The moment you are given that, the examiner is not wasting their time because they want you to use that information later on in the calculation. 1 mole of our hydrated salt would form 1 mole of copper 2 oxide. So what is meant by 1 mole of copper 2 oxide? Several answers here are acceptable. Okay, when we say 1 mole, you could say you are referring to that mass which contains particles which are exactly equal to the Avogadro constant. You are looking at the mass which contains 6.023 times 10 to the power 23 atoms. That's also 1 mole. Okay, but a person could also say, when you are saying what do you mean by 1 mole, you could also say, okay, you are you are actually referring to the mass that is exactly equivalent to the relative molecular mass. Okay, that becomes 1 mole, because moles are a way of counting. Okay, so you could say a mole, okay, the mass, okay, the mass that is equivalent is the mass that is equivalent to, okay, the relative molecular mass of a substance, okay, of a substance. So you could actually say that can be referred to as the 1 mole, okay? For instance, if I were to give you water, if you calculate, okay, the relative molecular mass of water, you get 18, okay? So if a person gives you 18 grams, okay, of water, you have 1 mole of water. If a person gives you 36 grams of water, you have 2 moles. So that mass, which is exactly equivalent to the relative molecular mass of a substance, could be regarded as its molar mass, or it's 1 mole of the substance. Okay, right. So that is the answer, expected answer for C part 1, and expected answer for C part 2. Okay, now let's move on and look at the other expected answers here. All right, I want to move down my screen, so I am going to sort of rub, okay, what I've written. I hope you have seen the answers there. They are fairly straightforward, okay, and make sure you don't make your answers too long. The most important points are supposed to be written because the examiner is checking for keywords, okay. So I'll rub that, and then we move down. Okay, right. I am rubbing it because I want to move down. Okay, right. Now this is where you are supposed to perform your calculations. Okay, right. So it says C part 3, 7.26 grams of a hydrate formed 2.4 grams of copper 2 oxide. Number of moles of copper oxide formed. Now, students, you need to remember, okay, you need to remember this triangle, okay? I always tell my students that whenever you are dealing with your stoichiometry, okay, remember this small triangle, okay, whereby you have N as your number of moles, okay, and your M, all right, is your mass given, and then you have your MR, which is the relative molecular mass. Okay, so this little triangle actually summarizes all the 3 formulae that are important for this particular question. Mass, number of moles, relative molecular mass. Okay, so we are now being asked to calculate what? We are now being asked to find the number of moles. Number of moles, according to this small triangle, is the mass given over MR. So if you look at the mass that has been given for copper oxide is actually equal to 2.4. So our number of moles here, okay, let's just put it as N. Okay, let me extend this here a bit. So small letter n is going to be equal to the mass given, okay, over capital letter M, small letter r, okay, and this will be equal to what, okay? So we have number of moles of copper oxide, we have 2.4, okay? 2.4, and then we have to find the relative molecular mass of copper 2 oxide. That's CuO, all right? The mass for copper is equal to 64. And then the mass for oxygen is 80. So that's 2.4 over 80. Okay, right. Let's do that together on our calculator. Okay, we have 2.4 divided by 80. What do we get? We get 0.03. Okay, so that is going to be 0.03. Okay, moles. So we have done the first one. Okay, we have done the first one. Number of moles of copper oxide is equal to 0.023. Okay, and then you have been told number of moles, okay, number of moles of the hydrated copper nitrate in 7.26. Now we need to go back to what we were told, okay? This line here is very, very important, okay? 1 mole, okay, of the hydrated salt will produce 1 mole of copper oxide. That statement is very, very simple because we are going to use it here, okay? We are going to use that same statement to say, okay, we produced 0.03. So what does that mean? It means if it is 0.03 for copper oxide, it also means it's going to be 0.03 for our hydrated salt. So this one, no need for calculation at all because we've already calculated. If it was 0.03 at the top, it's going to be 0.03 for the hydrated salt. So our answer is going to be 0.03. Okay, moles. Where am I getting this? I'm using the stoichiometry that I've been given, that 1 mole of the hydrated salt will give me 1 mole of the copper oxide. Okay, right. So we have done the first part, we've done the second part. Let's move on to the third part. Okay, mass of 1 mole. Okay, mass of 1 mole. Now we want MR. Okay, mass of 1 mole. Now we are looking for MR of our hydrated salt. Okay, right. So what we do here, we simply have to look at our formula. Okay, we simply have to look at our formula here. Our formula is going to be MR is mass given over N. All right, what is our mass given? Our mass given is 0.03. Okay, and number of moles is N. So it means what we are going to do is we are going to take the mass given. Here I want to calculate MR. So it's going to be all right, let me just tick so that you can see what I'm talking about. I want to calculate MR, so I'm going to take M divided by N, okay? And then what I'm going to then do is I will come here and then I am going to say my N, okay, is 7.26, which is the mass given, over 0.03. So I'm going to say 7.26 divided by 0.03. Okay, if you do that, you're going to get your answer here. Your answer here is going to be 242. Okay, if you just do that calculation I've just told you, your answer is going to be 242 grams. So it means the mass of the whole hydrated salt is going to be 242, including water. Okay, but we have been told that mass of the nitrate only without water, okay, is 188. The mass of the whole thing is 242, but the mass of the nitrate salt without water is 188. So I should be in a position to find the mass of water. Okay, so first of all, if I come here, all right, if I come, let me just put my answer here. If I say 242 minus 188, okay, I will get 54. So it means the mass of water is 54. Mass of water only is going to be 54. But I want to find the number of moles of water because the X stands for the number of moles of water. Okay, so for me to find the number of moles of water, I again come here. Number of moles would be 54 divided by 18. All right, so number of moles for water is going to be 54 divided by 18. And if you do that, you're going to get 3. Okay, and your answer here, which you are going to put down here, your answer, which you are going to put down here, is going to be 3. Okay, that's how you calculate the value of X in this hydrate. Okay, mass of 1 mole, which we have calculated, was 242. Okay, that includes water. But mass of 1 mole of the nitrate only, the anhydrous without water, is 188. So you're going to say 242 minus 188, you get 54. 54 is mass of water. But how many moles of water are present in 54 grams of water? You divide 54 by 3 and then by 18, and then you get 3. So students, that's how you'd actually handle the calculation on stoichiometry. This was a very good question because it was guiding you stage by stage. It's different from being asked to calculate the final answer. They were actually getting to the final answer stage by stage. And I suppose such questions are very good. And obviously, it also encourages students to progressively get to the correct answer by doing the calculation step by step. Okay, I thought I should just share with you how to solve this question, which came in paper 3 in May, June 2015 of chemistry 0620. Thank you. Bye-bye for now.